Dave, I understand you built this thing.
Yeah, it's the original wood stove, Frank. Now this simulates the whole oven burner system, where you have the regulator coming in off the tank, the thermostat, the glow bar, the burner, the oven gas valve, and then your gas fittings in between. One thing about glow bar systems is, we talked earlier about AGA, American Gas Association, being the UL equivalent. They require us to have a manual shutoff valve on every gas oven, and that's in case something happens and a malfunction occurs and the customer needs to turn the gas off to the oven manually. With the standing pilot and the spark system, your thermostat serves that purpose as a shutoff. And with the glow bar system, you can see that the thermostat is strictly an electrical device here. The gas doesn't flow through the thermostat. So anytime you've got a glow bar, you've got a shutoff valve located on that appliance somewhere remote. It has to be in an area accessible by the consumer without tools and without moving the appliance. If you're a technician and you can't find it, the mini manual will show you where it is. On this particular model, the shutoff valve is located down on the regulator. This is your shutoff valve right here. So, I don't know how many times I've talked with a tech who says he's replaced the glow bar, he's replaced the valve, the glow bar again, and the things still don't work, only to find that this shutoff valve is turned off.
If it doesn't have an indication of whether it's on or off, does it?
No, it doesn't. It doesn't. Good indication of if that's turned off, the symptoms will be on a double burner model. Neither burner will work.
Okay.
Okay. This has no effect whatsoever on top burner, strictly the oven burner.
Oh, okay.
Okay. So if in any event, you need to check the position of the shutoff valve first if everything else checks out. Glow bar glows and everything looks good.
What position is this one in here?
This one is off.
Okay, what do you have to do?
Okay, just flip this up. Now, with this type of regulator or this type of shutoff valve, it'll always be located on the back of the appliance.
Okay.
I told you it has to be accessible from the front. There are holes where you can reach your finger in there and flip this up if you know where it's at.
Okay,
so
you have to either be psychic or look at the mini manual.
Either look at the mini manual or if the customer has the installation instructions, it's normally in there also.
Oh, okay, good.
And we're in the process of adding this to the user manual also.
Well, Dave, let's fire this thing up and see it working.
Okay, Frank, I want to check the amps. Like I said before, that the system is more amp-driven than anything. And let me turn the thermostat on and put this clamp on amp meter in place.
I see it's increasing as time's going on.
Okay, we ought to see it go up to about 3.2 amps before that valve opens. And as that igniter heats, the resistance of the igniter drops so that the amperage in the whole series circuit increases. And there it goes.
So now it's dropping back down. It went up to about 3.1, I think, and it dropped back down.
Right, it's normal for it to drop back just a little bit. Okay. And with a series circuit, you can measure this amperage anywhere as long as you just get one single lead, whether it be on the power cord or down at the valve or just anywhere you can conveniently grab a hold of a lead, or wrap around a lead, I should say. Okay. All right.
Okay, Dave, you checked the current. Now what?
Okay, Frank, oftentimes when a glow bar starts to go out, you'll get the glow, but you won't get the flame. The burner won't light, but you still have the glow there. And what's happened is the glow bar has started to age, and it's getting weak, and it just won't allow the proper current draw. And you're not going to find that problem unless you have an amp meter. The amp meter is the only way to locate that. We can simulate that. We can turn the burner off.
Okay.
And we can lower our voltage here to about 70 volts.
Okay.
And what you'll see...
We'll let it turn off.
We'll let it turn off here. What you're going to see is the glow bar will glow, but the amp meter won't get up to 3.2 amps, which is what we need for this type of glow bar. Okay.
Okay, I see the glow bar is starting to glow.
Right, it's going to glow, and
the meters.
After a while, I believe a tech will develop a knack for looking at the glow bar and the color of the glow and determining by the color of the glow that it's just not pulling the right current. Because we noticed a while ago it got up to a white hot.
It's right around A little less than 2 amps.
Okay.
Hey, you're right, it's not lighting.
What I'm trying to say is it is glowing, but the burner's not lighting.
Okay, let me turn this up while we have it hooked up. Is that all right?
Yeah, sure.
Okay, we're up to 120 volts now.
The glow bar got much brighter. And our
Okay, we're
amperage
up
came
above 3 amps again. There we go.
Now we have flame.
Oh, good.
Okay. Great.
What else should a technician look for as far as problems on this thing?
Well, we already talked about the shutoff valve. That's probably the most common problem. I guess the most common thing they see is glow bar won't glow. And sometimes you can look at the glow bar and you can see where it's broken.
Oh,
and
okay.
obviously you need to replace it.
If it doesn't glow at all, it's obviously bad or some connection to that.
Well, it's not necessarily bad, but if you can see physical damage to it, then you know it's bad. But if you go out and it doesn't glow, the quickest thing to do is kill the power to the range and use an ohm meter. And most of the glow bars out there are wire nutted. Okay, some of them still come from the factory with plugs, but a lot of them use wire nuts, and the repair igniter will come with wire nuts. So if you go out and the glow bar is not glowing, what we need to do is break this connection right here. Of course, kill the power first, and here we can just flip the switch since we're on a variac. Okay, disconnect your leads. Okay. That was on there good. There we go.
So you can just take an ohm meter, read across it, and you should measure a couple of ohms. I mean, I'm sure it's really not.
Right. We'll take an ohm meter and measure across here. And it's really a 3-stage process.
Okay, you want me to do that?
Yeah, sure.
Okay. You know I don't like this meter, but we're going to do it anyway.
Okay. And the first reading I would take would be the resistance of the igniter itself.
Okay, here, you go ahead. I'll look at the meter.
Okay.
54, 55 ohms.
Okay, now that's going to vary. It may be 50, maybe 150, but what we're looking for is a short or an open.
Okay, so if you read 1 or 2 ohms, it's shorted.
Right.
Or if you read that, well, if you read something like that, you know it's shorted. Or if you read something that looks like this, you know it's open.
Right.
Okay.
Okay, so if the glow bar checks out good, you got about 50 ohms or 150, somewhere in that area, 50 to 150. Then we need to check voltage. The next step would be to turn the power back on and check the voltage. Before you turn that power back on, set our meter back on scale there. And we'll check our voltage from the wire coming from the thermostat to the wire going to the valve.
Okay, you want me to turn it on?
Yeah, if you would. Okay, now if you turn the thermostat on.
Of course, it helps having 3 hands.
Yeah, it does.
Okay, 121 volts. That's
okay,
fine.
so we know we got power available to the glow bar. The glow bar's not glowing, so obviously we got a bad glow bar.
Sure. Okay, makes sense.
Okay, and if we check that, if we were to check it from the lead coming from the thermostat to the lead, like we just did, to the valve.
Leave it on.
And got nothing. Okay, that would be a pretty good indication that the valve is open, or the thermostat's not good. And from that point, I would check it from the lead from the thermostat to ground. If I got voltage there, and I didn't get it from the thermostat lead to the valve lead, then I know my valve's open. Then all I have to do is take a ohm meter check across the valve. I should have about 1 ohm across that valve.
Let's look at it now. Let me turn this off, just to make sure.
Right. We're on ohm scale?
There we are.
Okay, now I only have about 1 ohm across that valve.
1.5, 1.4, close enough.
Okay. So I know the valve's good.
Yep.